Welcome to the data metaphor space. First of all, please invite our two guests, Mr. Kakashi and Ms. Catwoman. Today, our topic is how to choose an array or a linked list when you plan to watch a movie with your friends. Before the show starts, please ask two guests to say hello to the audience.
The task is almost full. Oh, I plan to watch a movie with my friends. Well, I went to the movies with my friends. And when I found a place to sit, another friend came. But if I sat, there is no empty place in the place. So I have to find another place where everyone can sit down. In this situation next, you have to request the computer to reallocate a piece of memory that can hold 4 to-do items. And then all to-do items are moved there. Now, if another friend comes, and there is no room at the place where you are sitting, you have to turn again shift. It's too much trouble. Similarly, adding new elements to the array can be troublesome. If not with space, you have to move to other places in memory, so adding new elements will be slow. One solution is to reserve seats. Even if there are currently only 3 to-do items, please ask the computer provide 10 locations in case you need to add to-do items. In this way, as long as the to-do list does not exceed 10, no need to transfer.
This is a good contingency measure, but you should understand that it exists as the next two shortcomings. First, the additional location you requested may not be available at all, which will waste memory. If you don't use it, no one. After more than 10 to-do items, you have to transfer. Should I use an array or a linked list? Since the array is easier to grasp, we first store the to-do list in the array. Using an array means that all to-do items are connected in memory, next to together. The elements in the linked list can be stored anywhere in the memory. Each element of the linked list stores the address of the next element, so that a series of random memory addresses are stringed together.
How to choose an array or a linked list when you plan to go to a movie with your friends. Let's look at an animated demonstration of the stack, array and linked list. The 1, 2, 3, 4, 5, etc. below are the serial numbers of the array. We now demonstrate the push and pop operations of arrays and linked lists. Here, we demonstrate arrays and linked lists in the stack. In fact, arrays and linked lists have similar existence in queues and lists. In the future, we will also demonstrate the execution process of arrays and linked lists in queues and lists.
This is like a treasure hunt. You go to the first address, and there is a note that says, next Yuan Sus address is 123. So, you go to address 123, where there is another note that says, next the address of an element is 847, and so on. Adding elements to the linked list is easy. Just put it into memory and store its address in the previous element. When using a linked list, there is no need to move elements at all. This can also avoid another problem. Suppose you went to watch a popular movie with 5 friends. The 6 of you want to sit together, but the people watching the movie not 6 seats together. This is sometimes the case when using arrays. Suppose you want to allocate 10,000 locations for the array. There are 10,000 locations in memory, but not all together. In this case, you will not be able to allocate memory for the array. Linked list is equivalent to say, let's sit separately. So as long as there is enough memory space, we can allocate internal live.
The elements of the array are numbered, and the numbering starts from 0 instead of 1. For example, in the following array, the element the position of prime 20 is 1. The position of element 10 replace me as 0. This usually confuses novices. Starting from 0 let the array-based code is easier to write. So programmers always insist on doing this. Almost all programming languages, in other words, the array elements are numbered starting from 0. You will get used to this practice soon. The position of the element is called the index. Therefore, instead of saying, the position of element 20 replace me as 1, the position of element 20 is at index 1. The index will be used to indicate the position.
Thank you two guests for the discussion and sharing today. Let's see you next time.